I'm here to talk about pesticide formulations and why you should know about them. But in a nutshell, pesticide registrants formulate their products to make them safer, more effective, or easier to use. Now, that said, they could send enough of a particular product to a county in 99% technical grade in a really small package, but they don't do that for a number of reasons. For one thing, the more concentrated, the more toxic. For another thing, the more difficult it would be to measure. For another thing, an individual user wouldn't want this much material. And we certainly don't want to invite redistribution or anything like that. So products are formulated, again, to make them safer, easier to use, or more effective. Now, as educators, we want people to understand the properties of formulations for a lot of reasons. In every core manual, there's a unit on formulations. So on the certification exams leading to an applicator's credential, there's going to be questions on that content. In order to choose the proper application equipment, you have to know what formulation you're dealing with. As an educator, you are going to need to use materials when you teach pesticide safety education and teach many of the topics such as calibration, such as risk reduction and exposure. For example, if you're teaching somebody to calibrate a drop spreader, something has to fall out of that spreader that you can collect and measure and show people how to calibrate it. Similarly, if you're going to calibrate a backpack or a boom sprayer, something has to come out of that nozzle. If you're going to demonstrate incompatibility, you're going to have to mix products to show what happens when they aren't compatible. When you are doing experiments or demonstrations or activities to model what to and what not to do for pesticide exposure, the folks have to have something to handle. So the point of this next little bit is to show you some safe, commonly used products that you can get your hands on easily and without a lot of expense that have the same properties, that behave the same way as formulated pesticide products. All right, I'd like to start with about dry products. We'll start here with granules and pellets. And when I began this, I was kind of thinking granule, pellet, what's the difference? Well, in fact, a granule is a small piece of gritty material that you can simulate with kitty litter, among other things, but that's a good option. On the other hand, a pellet is a material that's cylindrical in cross-section, an extruded solid, and a true pellet, a real good pesticide pellet, would be cut to specific lengths. These animal feeds maybe not so much. But for example, if you request from a chemical company blank pellets, they will come, for example, a very specific circumference and a very specific length, like maybe 1/8 of an inch. But you could use most animal feeds in pelleted form to be your fake pellets. Now, for a soluble powder, you've got plenty of options. One certainly would be powdered sugar. Concentrated drink mix like Gatorade or Kool-Aid would work, granulated sugar would work, but for many reasons I'm going to kind of push the powdered sugar, which may become obvious in a minute. You can use, for a wettable powder, flour. And for a dust, you can use talcum powder. Now, let me show you an example of what I would do. If many people are going to have the life experience to understand why I just said is right. But if you have a bunch of newbies or youngsters that haven't had a lot of kitchen time, they may not realize that even though all three of these, the powdered sugar, the flour, and the talc, look like white powders, if you put them in a dish or a bowl or a petri dish, they might be hard-pressed to tell which is which. However, they behave real differently, and you could either show them or show them the end result and say, okay, which is the floater, which is the sinker, and which is the true solution. And in fact, when you put powdered sugar into water and stir it up, you're going to get a true clear solution. The only way you would know there's any sugar in here is to taste it. On the other hand, when you put flour in here, which is like a wettable powder, it sinks to the bottom, and if you agitate it, it'll form a suspension, different from the solution because it's cloudy. And if you let it alone, the stuff's going to settle to the bottom. On the other hand, the talc, no matter what you do, no matter how hard you stir, no matter how hard you agitate, it's not even going to mix. It's just going to float on the top. Now, the point you can make here is this is a sprayable formulation, and you could use virtually any kind of spray application equipment for it. This is a sprayable formulation too, but if you don't have agitation, you're not going to have uniform distribution of the mixture. And last but not least, this isn't meant to be sprayed. This is a ready-to-use product that doesn't get mixed with water at all, which is a good thing because it won't. Now, I want to talk about two specific dry formulation products for a moment, and that is the simulated wettable powder, as stated, was flour, and a simulated water dispersible granular or dry flowable product would be powdered milk, for example. I think you could use grits, although it's not quite as good a ecological equivalent. The thing is, wettable powders kind of becoming dinosaur formulations, and the reason is they're messy. You open the bag of flour and poof, you've got some fine dust on you. You have to reach down in the bag to scoop some out. You're almost inevitably going to have some skin exposure. Then you have to take this stuff out, and it was measured by weight, so you had to put it on a scales and you had to weigh it. And then, because it doesn't like to dissolve in, well, won't dissolve in water and doesn't particularly like to suspend, you had to either do like you were making gravy, either have to mix it into oil and then add water, or you had to use a tiny bit of water to make a slurry or a paste and then gradually add more water, all the time agitating the tank, or the stuff's going to settle on you. So for a lot of reasons, this has become kind of a passé formulation. However, it's tough in some cases for these chemical companies to find a formulation that works. And some folks who had materials that were best delivered as a wettable powder have now gone to this water dispersible granule or dry flowable formulation product. And all they really are, in a nutshell, is this stuff squished into slightly bigger pieces. Now, what you gain, in a lot of ways, they have the same pros and the same cons. But what you do gain is ease of measuring. Some of them come with a little specific, and this is a blank, by the way, but some of them come with a product-specific pre-measured device where somebody else has weighed it and then put the marks on the tube, and all you have to do is turn the product upside down, rotate the little device, and it fills. And if you get too much, or in this case, if you want to put it back like I do, you just turn it the other way and back down into the container it goes. Some of them alternatively are made for open pores. But again, just like wettable powders, they are not water soluble. They're suspended in water. You have to have agitation to keep them mixed up. But what you gain, in a nutshell, is easy measuring, easy transfer, less likely to become exposed. They're way easier to handle, whether they come with this little device or whether you have to just pour them into a pre-calibrated tube. If you get a few granules on you, they're going to bounce off on the ground, as opposed to be powders that are going to coat your skin. So they're way easier to handle, and in many cases, in most cases that I know of, these dry flowables, water dispersible granules, have replaced the wettable powders. Now, sort of as a transition, truthfully, between dries and liquids, I'll talk for a moment about flowables. This isn't a real common formulation, but what you have here, in a nutshell, is ground up fine particles suspended in just enough water to make them pour. They are thick, they are goopy, they are hard to get out of a container. If you let a pesticide product that's a flowable dry in its container, don't rinse the empty container right away, it's going to harden in there and be hard to get out. A lot of the products that have this formulation are brand XF is what they use for that. But basically this is nothing but ground up fine particles and a little bit of water, so it will flow as opposed to pour the way the water dispersible granule did. And a good equivalent for that, or a good substitute for that, would be Pepto-Bismol. Many liquid formulations are either emulsifiable concentrates or concentrated solutions. An emulsifiable concentrate is a liquid material, but it's got some kind of an organic solvent such that it does form an emulsion or a suspension, not a true solution. One way to tell this is if I pour this material into water, it turns cloudy. And you can see that it's not a true solution. It requires modest agitation to get it to remain as a uniform mixture. On the other hand, these true solutions do dilute and would form a clear or transparent solution, not a cloudy or milky suspension. And last but not least, we're kind of blurring the line here. This is a ready-to-use solution. You've got both formulation and packaging going for you, because in many times not only are they ready to use, but they're sold in their application or delivery device. I'm going to pick up here with what I talked about a second ago, which is both a formulation and a delivery method. This is a ready-to-use solution, but more often than not, these things are sold in the delivery device or the application equipment. And an aerosol is a good example of that. You've got a formulated product, but in a device to deliver it. For example, wasp and hornet spray. This allows you to treat the wasps and the hornets without getting within striking distance, so to speak. So you can reach out and touch them and they don't get you. Many pesticides are sold as fogs or fumigants, and you could simulate that with the vaporizer type thing, one of these plug-ins or one of the other type devices you can purchase. Microencapsulated, unfortunately, I don't know of any product they make now that's a little capsule you can see through and see the little beads in the capsule, but timed release medicine can give the same effect as something that's microencapsulated. We also have materials now, pesticides sold in water-soluble packaging, as we have dishwasher detergent and medicines that are also sold in water-soluble packaging, like these gel packs and this cleaner. And then baits are kind of all over the lot. You've got plenty of options, and in some cases, a granule or a pellet is also used as a bait in or out of a station. You can buy them in blocks, which perhaps this granola bar can help to simulate. You can buy gel for ant and cockroach baits. Used to be the professionals could get it, but now you can get ant gel at the big box stores or the grocery store and streak it along where the ants are walking, and they go for the sweet gel, which is also poison, and you can show that with some of this icing.